In this video, we're going to solve one-step equations. Let's read the directions. Solve for the variable in each of the following equations. Write your answers as whole numbers, proper fractions, or mixed numbers in simplest form. So let's look at the first one. We have x plus 14 equals 16. So this means we're looking for some number x, which is unknown, and when you add 14 to x, the result is 16. So you may be able to figure this out in your head. I know that if I add 2 to 14, I'll get 16. And that's a good way to start, but you need to learn to use the principles of equality so you can solve more difficult equations later. So here's the idea. We have an equation or a balance point. So for example, if I had $5 and you had $5, we'd have the same amount of money. If we wanted to keep this equation true and I had $2 more, we'd also need to add $2 more to the amount of money you have. Notice we've changed the value, but what we're doing here is we're maintaining the equality. The two sides are still equal. And this is the idea we're going to use here. So we want to find out what x is, but right now x has 14 added to it. So to undo adding 14, we're going to subtract 14 from this side of the equation. And whatever we do to one side, we have to do to the other. So you want to look for the equal symbol, go to the other side of the equation, and subtract the same amount. Now I'm going to put a line here showing that I'm performing the operations downward. So we have x, that's still there. Well, plus 14 minus 14, that's 0. I could write plus 0 or minus 0. Now I have the equal sign, I bring that down, and 16 minus 14 is 2. Well, we know when you add 0 to any amount, no matter what amount it is, it's just the number itself. So 3 plus 0 is 3, 5 plus 0 is 5. So we don't really need to put this plus 0 here. So we have the result, x equals 2. And that's what we thought it would be to begin with. So x equals 2. It's always a good idea to verify or check your answers. You go back to the original equation and you take the value of x that you found, or the letter, and you replace it and evaluate. So is 2 plus 14, is this equal to 16? And I put the question mark because I'm officially not sure yet until I perform the operation. And we have 2 plus 14 is 16, and the equation checks. Or the solution checks. So let's try the next one. R minus 14 equals 16. So here we have an amount subtracted from our unknown letter r, and we want to find this amount. So to undo subtracting 14 from from this side, we want to add 14 to the left-hand side, and I'm lining it up with the minus 14 so they'll line up to subtract, and also to the right-hand side of the equation on the other side of the equal sign. So now I have r. We know minus 14 plus 14, they're opposites, they cancel each other out. I could put plus 0 like we did here, and you can still do that, but I'm going to skip that step now that we're familiar with it. R equals 30. So now let's check our result. Well, I'm going to replace r with 30. Does 30 minus 14, does that equal 16? And if we do this subtraction, we will in fact get 16 again. So this checks. So our answer is r equals 30. Let's try the next one. N plus 10 equals 17. So there's a number, and if I add 10 to it, I get 17, and I want to know what that number is. So I want to remove this plus 10, this adding 10, so I'm going to subtract 10 from both sides of the equation. There's the equal sign. I'm going to put the line showing I'm performing the operation downward. So here I get n, these cancel, and 17 minus 10 is 7. Checking my result. Does 7 plus 10, does that equal 17? And if we add 7 and 10, we'll see that that result checks as well. So our answer is n equals 7. Now this next one's a little bit different. In the 3 previous cases we had a number added or subtracted, but here we have 12m equals 8. And remember, 12m is the same as 12 times m. We just write 12m for shorthand. Okay, so let's just see, looking back at our principle of equality like we talked about up here, if we had, say, I had $20 and you had $20, those two values would be equal. Okay. And maybe we want to divide the amount I have by 5. I share my $20 with 5 friends, and they each get $4. Well, in order to keep this equation equal, you would also have to do the same thing, divide yours by 5, and we get 4 equals 4. So the original 20 equals 20, that's true. We divided both sides by 5, we get 4 equals 4, which is also true. So multiplying or dividing both sides of an equation also maintains equality, and that's the idea we're going to use here. So since 12 is multiplied by m, to undo multiplication, we can divide. So I'm going to divide both sides by 12. Here's my left-hand side. Excuse me, here's my right-hand side. Well, 12 divided by 12 is 1m, which we usually just write as m. And then we have 8 divided by 12, which is a fraction. Now I'm going to look back at the directions because I remember they had some specifications for our answers. So it says whole numbers, well, we have a fraction. Proper fractions, well, this is proper because the numerator is less than the denominator. In simplest form. So this is not in simplest form. I'm going to move this on up here. M equals 8/12. 8 and 12 both have a factor of 4, so I'm going to write this as 4 times 2, and 12 is 4 times 3. And now the 4's cancel, and we get a result of 2/3 as our simplified answer. So we have m equals 2/3. Now let's just check this. So 12 times, instead of m, I'm going to write 2/3. And does this equal 8? Well, here I'm going to put 12 over 1, and we can multiply these fractions. I'm going to cancel out the common factor of 3. So both 12 and 3 have a factor of 3. So divide that by 3, divide this by 3. And now on the left we'll have 4 times 2 over 1 times 1, which is just 8, equals 8. And since this equation is true, that means our answer checks.